This is a question that plays on one of the common misunderstandings about average velocity. So if we have a trip with two segments, constant speed, say speed number 1 on the first segment and speed number 2 on the second segment, the average velocity is not the average of those two speeds. It might be under very special conditions in which the two segments take exactly the same amount of time, but in general, the average velocity is not equal to the average of the two individual speeds. Instead, average velocity, so V average, equals total distance divided by total time. That's what we need to figure out the average velocity. We need the total distance, we need the total time. We have the total distance already. So all we need to figure out the average velocity is the total time. So which of the following statements individually provides sufficient information to determine the average velocity of her trip? Well, A, if we're given the total time, total distance divided by total time is average velocity. A gives us exactly what we need. B is the trap answer. If we have the average of the two speeds of the two individual segments, that doesn't tell us zilch. That is useless. But it's a trap answer because many people think that you get to the average velocity by averaging those. So that's wrong. So the distance of each segment, that doesn't help us at all. Interesting, if we know the time spent on each segment, then we could add them together and get the total time, and then we could compute the average velocity. So that would help us also. The speed on each segment, that doesn't help us. So the only answers that work here are A and D. Okay, City A and City B are connected by a straight 420-mile road. We have Nigel going one way, Phyllis going the other way, and we have the two speeds, and we want to know how many miles apart will they be 1 hour before they meet. So we could do this in very complicated ways, introducing all kinds of algebra, but let's just think about this. They're going in opposite directions, and so that gap between them, the gap will be shrinking at the velocity that is the sum of those two velocities. So 49 plus 56 equals 105. The gap between them is shrinking at 105 miles an hour. And so that means in any 1 hour, it's going to get 105 miles smaller. And so in the last hour, it would have to get 1 hour, when they're 1 hour apart from each other, they'd have to be 105 miles apart so that they would wind up at 0 miles apart in an hour. And so they definitely have to be 105 miles apart. And that is the answer.
All right, to begin, let's let M equal Murray's current age, in which case M plus 12 will equal his age in 12 years. So here's Murray's current age, and here's his age in 12 years. At the moment, these two ages are not equal. The question tells us that his future age here is 4 times his current age. So if we take his current age and multiply it by 4, then these two ages will be equal. At this point, we'll solve for M. First, we'll subtract M from both sides, and now we'll divide both sides by 3 to get M equals 4. So Murray's current age is 4 years old. The question asks us how many years until Murray is 8 times as old as he is now. In other words, until he is 32 years old. Well, it will take 28 years for Murray to be 32, so column A is equal to 28, in which case it is greater than column B, and our answer is A. We're going to solve this question using a double matrix. Our two criteria here are being male or female and having an MBA or not having an MBA. Since we are not told the number of employees, we'll say that there are 100 employees. Now the question tells us that 40% of the employees are female, so we must have 40 female employees. This means that the two lower boxes will add to 40. If there are 40 female employees, there must be 60 male employees. Of those 60 male employees, we're told that 30% of them have an MBA, so 18 male employees must have an MBA. This means that the remaining 42 male employees must not have an MBA. Of the 40 female employees, 50% of them have an MBA, So 20 female employees have an MBA and 20 do not. So as you can see, there is a total of 62 employees that do not have an MBA. So our percent is 62%. Our answer is D. Okay, for questions involving present and past ages, I like to set up a table. For this question, we'll let X equal Roberta's present age. And since Jean is 7 years older than Roberta, X plus 7 will represent Jean's present age. Now, if Roberta's present age is currently X, then 6 years ago, her age would have been X minus 6. Similarly, if Jean's present age is X plus 7, then 6 years ago, his age would have been X plus 7 minus 6. So here's what we know about their ages 6 years ago. 6 years ago, Roberta's age was X minus 6, and Jean's age was X plus 1. Now at the moment, these two ages are not equal. The question tells us that Jean's age is twice Roberta's age. So if we take Roberta's age and multiply it by 2, this will be equal to Jean's age. From here we can solve for X. First we'll expand the left-hand side, and now we can solve for X to get X equals 13. Now we know that X represents Roberta's present age, so we now know that column A is equal to 13, in which case it is greater than column B, in which case our answer is A. We can solve this question using ratios. Let's let X equal the number of feet the object can travel in 1 hour. And we'll set up our ratio as follows. We'll compare the number of feet traveled with the number of seconds elapsed. So we're told that this object can travel 100 feet for every 2 seconds. We'll now write an equivalent ratio, X, and we want to know how many feet this object will travel in 1 hour. So rather than write 1 hour here, since we're dealing with seconds in this ratio, we will write 3,600. In other words, we want to know how many feet the object will travel in 3,600 seconds, which is the same as 1 hour. And now we can solve this for X. Let's cross multiply. And we can simplify on the right-hand side 100 times 3,600. And we'll divide by 2. What does this tell us? This tells us that this object will travel 180,000 feet in 1 hour. We want to know how many miles this object will travel in 1 hour. So we need to convert 180,000 feet into miles. Well, we know that there are 5,280 feet for every mile. So we take our 180,000 and divide by 5,280. Now before we perform this lengthy calculation, let's take a look at an easier calculation. 180,000 divided by 5,000 is equal to 36. So what happens if we take 180,000 and divide it by a number slightly larger than 5,000? Well, our result will be a number which is slightly less than 36. So our answer must be 34. This is the only answer which is slightly less than 36. The answer is C. All right, to calculate the distance in column A, we'll need the following formula. Now keep in mind here that column A requires us to determine the distance that light can travel in 1 hour, while the question gives us the speed of light in kilometers per second. So our first step here must be to convert 1 hour into seconds. Now 1 hour equals 3,600 seconds. So we can think of column A as really asking us the approximate number of kilometers that light can travel in 3,600 seconds. This will be equal to the time, 3,600 seconds, times the speed. We now need to evaluate this. First, I'll multiply 3,600 by 3 to get 10,800. And now I'm going to rewrite 10,800 in scientific notation, which will multiply by 10 to the power of 5. Finally, we can combine these two powers to give us 10 to the power of 9. When we compare column A with column B, we see that column A is greater, in which case our answer is A. All right, to begin, let's let G equal the price of 1 gumball, L will equal the price of 1 lollipop, and C will equal the price of 1 chocolate bar. So our goal here is to find the value of C. Now the question tells us that the total cost of 1 gumball and 1 lollipop is $0.74. In other words, the total cost is 74 cents. So let's use cents rather than dollars here. So from this we can write the following equation. G plus L equals 74 cents. Similarly, we are told that the total cost of one chocolate bar and one lollipop is 92 cents. So we can write this equation. And finally, if the total cost of one gumball and one chocolate bar is 124 cents, we can write this equation. We now have three equations and we want to solve for C. How do we do this? Well, I'm going to begin with these two equations. Notice that if I subtract the bottom equation from the top equation, our g's cancel out, leaving us with C minus L on the left-hand side and 50 on the right-hand side. This is useful because I can take this equation now and combine it with one of the equations we created earlier. Notice that now if I take these two equations and add them together, we get C plus C, which is 2C, and we also get negative L plus L, which cancels out the L's. On the right-hand side, we get 50 plus 92, which is 142. So we now have one equation with C, the variable we're trying to find the value of. From here, we'll divide both sides by 2 to get C equals 71. So the price of one chocolate bar is 71 cents or $0.71. So as you can see, our answer is E.